Hi, my name is Ali, and in this video I'm going to demonstrate a LangGraph React-based agent deployed on Kagenti running on Kubernetes OpenShift platform. So this is a continuation from my previous video where I've demonstrated a similar Kubernetes SRE agent remediating Kubernetes issues or through OpenClaw skills. I have described how I have done end-to-end POC to production, which is OpenClaw to Kagenti, in this blog post, and I'll leave the link in the description below. A quick overview, a quick description about what Kagenti is. It is now it's known as Rossoctl. It provides a set of platform primitives for agent security, resilience, and efficiency, and these are some really important components when we try to productionize an agentic system. So without further ado, let's get into the demonstration part. Before I go into describing the agent, it's important how the agent is harnessing the AI or LLM. So in this particular case, I am using Qwen 3.4b model, which is a very small size LLM. Right now on this, so I've deployed it on a OpenShift AI on OpenShift AI using model as service, and the server has only an L40 GPU. I have also tested this on RTX 3060, so it does not require a massive GPU power, and that's the crux of the problem that we're trying to solve here. So after I deployed the model on OpenShift AI, it provides me a endpoint URL with token, and that's how I am consuming this model as inference endpoint. Okay, so I have already deployed Kagenti in my Kubernetes OpenShift Kubernetes platform, so it's running. What I have in front of me now is the Kagenti dashboard. As you can see, I have deployed only one agent so far, but there are plans to do more. And it's in ready state. I also have deployed Kubernetes MCP server, which is the OpenShift Kubernetes MCP server, on this Kagenti platform, and it is being served to the agent via the MCP gateway. If I go into this MCP server, I can see from the Kagenti UI, I can list down the tool that it has in it, it can serve. And looking at the list of the tools, it's very apparent that that most of, if not all, of the kubectl commands are available through this set of tools. So it's important that we put proper governance and security around it. In my case, I have filtered the number of tools that is only required for my use case using via the MCP gateway, and I have also secured this tool through workload identity, which is also something that Kagenti integrates with, so that nothing can get to this tool without proper authentication and proper authorization. Okay, so now that we have covered what Kagenti is, oh, by the way, I just wanted to quickly show, here is my agent, and we'll get to that in a second. I'd like to introduce the application in question. So that's the UI of the application. It's a very simple microservice-based application, which has got a couple of services, and they talk to each other via Kubernetes service. The only thing that's exposed on the internet is this, and that's how I'm accessing the front end of this application. So it's a very simple application. It connects to a backend database and pulls a record from it. Right now there is no record in it. Let me add a record very quickly. So what this does, it hits an endpoint to the backend app, which is this service, and that reaches out to the publicly available API for international space station location. So I think the API is having some trouble there. So let me add an input manually. Okay, so I've added an input manually, and I can pull that from the DB. So that's looking good. Let me add one more. So that works too. Okay. So now let's break. Oh, here you go. So now it finished. So it pulled. So the backend service reached out to the the NASA International Space Station and pulled this information. So this is the latest one now. So if I do a latest code again, oh, that's not the latest one. Let me try that one more time. Probably the public API is slow, so that's why it's taking longer. But that's another point. This is something that can cause a microservices app to break down. So to simulate the breakdown, let's cause some havoc in the app. So what I'm going to do is I am going to first delete the Postgres service. So that means the application loses its connection to the database. So if I try to pull the record, I'll hit this error. If I try to add a new record, I will also hit the error. Okay, so that's horrible. At this point, I'll also delete the config reader service. What that means is if I try to reload this config, it will fail. So it will keep on throwing errors, right? Okay, so now it's time to remediate this. So what I'll go to Kagenti, I'll go to my agent, and I will ask it to fix it. There is a cron job running in the background that pings the agent every 1 hour, and the agent does things autonomously. But in this case, to demonstrate, I am going to do it manually. I'm just going to say hello. And it will give me a response. I have restricted this agent down to, so it only knows about Kubernetes, and it won't answer to anything else. Okay, so I'm gonna say run, because I forgot the command. So I need the agent to tell me what command to run. So this is the specific command that the agent looks for to start executing the finding and remediation task. So it started processing, and it should send notifications very shortly. So it has already sent me some notification. Let's have a look. So it has found the issues and how many times it has occurred and what is the remediation that it's going to apply. So an important thing to note here, the agent is not acting on its own. In terms of what remediation should be applied, I have suggested that through a knowledge base. I have described all of that in my blog post. Okay, so we'll wait for the agent to do the remediation. Here we go. So now we have the remediation as well. And so it looked like it tried to create the backend service, and that failed. That wasn't our main issue, so that's okay. Then it identified that the PostgreSQL service is missing, so it recreated it. It also identified that the config reader SVC was missing, and it recreated it. And it has asked us to do some manual review. Okay, so looks like the agent has fixed our issue in the Kubernetes cluster. So let's have a quick look. So if I reload the services again, I can see that this service was created 72 seconds ago, and this was created 68 seconds ago. So what the agent is reporting is actually happened in the Kubernetes cluster. So I'm expecting my app to start working now. So I can immediately see that I can load the configurations via the config reader service. So that is back in action. What about the database pool? Yeah, I can see that it is now able to pull records from the database as well. Let's try to add a new record, and I can say hello agent. I have called it Kate's namespace agent. Sorry, this is monitor agent. That's what I've called it. Not a very creative name, but that's how I ended up writing the code. Okay, so it looks like the app is all back into working condition now. So that concludes our demonstration. I will leave the link to this blog post in the video description below. This is where I have described what I have done with OpenClaw, how it was a proof of concept, and then I moved on to deploying it onto Kagenti and how it's working in Kagenti. Thanks for listening. Thank you.